Hello, Azure friends. Good morning, good afternoon, good evening, everyone, and welcome to another edition of AZUGMNL Virtual Meetup. My name is Mariluck, and I'm the organizer of Azure User Group Manila. And our goal is to share knowledge and help uplift our Filipino Azure community. And we have a lot of talks and events planned for you in the future. So I hope I can continue providing you with all this valuable content and opportunities. So I'm asking everyone to support us and to help us keep this group a safe place for learning and for collaboration. You can support our group by joining us at meetup.com, Facebook. Just look for Azure User Group Manila or follow our Twitter account, as you can see here, or follow our YouTube channel. So we are always looking for volunteers, for speakers and sponsors, and just any kind of support that you can give to keep the community growing. So without further delay, I'd like to invite Mr. John Paul Ada on stage now. Here it comes. Hello there, John Paul.
Hello everyone.
Thank you for joining the stream. I'm so excited. I think we met on one of the first virtual ASUG Manila meetup, and we had a long discussion. Maybe it lasted
Yeah,
4 hours, remember? Yeah. I thought that was really fun. I hope we can do that again. But right now we only have 1 hour, and I'm actually, as you can see, doing this from our office in Denmark on my lunch break. I haven't eaten my lunch yet, and those are my colleagues behind me. Where are you sitting at?
I'm in my room.
Okay. I can see a lot of exciting stuff above your head. I'm not gonna even guess what those are.
Yeah, I just
Uh,
moved, so there's still a lot of stuff.
all right. Well, we have a very exciting topic for today: machine learning.
Mm-hmm.
It's always for me exciting because I know nothing about it aside from the word itself, machine learning, but I haven't really worked directly with it. How long have you been working with Azure machine learning?
A bit for a while. I'm not sure how long. So I've just been like playing around with it actually, but I don't really like since we don't really do cloud on my job. So I usually just play around with it on my spare time instead of using it on my work. But still, my work deals with uh, data to some extent. Yep.
All right, cool. But that's also very inspiring for our community to know that you don't have to do this on your day job. You can also just go ahead and play. And so maybe we can get a lot of tips from you on how to get started in machine learning. So then I will give you the stage if you would like to share your screen, and then
Okay.
I'm going to hop out. And by the way, for our audience here, feel free to just post your questions and comments on Facebook or YouTube. I will be watching out for it, and then maybe we can speak a couple of questions towards the end of the session that JP, can I call you JP or is it John Paul?
Yeah, JP would
And
be great.
JP, okay. Then JP maybe can answer some of them. And then um, just maybe we will pick the best question of the day and then we can send you goodies wherever you are in the world. We will try at least. So, yes, JP, do you want to share your screen?
Okay, I'm sharing it now. Share entire screen. There we go. I'm just gonna. So can you see my screen now?
Let me just add that. Yes, here we go. So, see you all later.
Awesome. Right. Hello everyone. My name's JP, and I'm one of the uh MVPs for artificial intelligence here in the Philippines. Microsoft MVPs for artificial intelligence, and I'm currently a data engineer at IBM. So what we'll talk about today is Azure machine learning. And so, let's just walk through what this means. Um, so first is machine learning, right? Machine learning is basically telling a computer how to perform a particular task, like letting it learn how to do a particular thing without being explicitly told how to. So, for example, if you want a machine to figure out what this particular person looks like, so for example, facial recognition, that kind of task, right? So, if you want a machine to learn how to do that, so one thing that you could do is actually like explicitly tell the machine how to do that. So like an example of that would be like to take the features of the face, and if this matches this person's features, then this is that person, this pictures of this person. So alternatively, what machine learning does is you don't need to figure out yourself how to, depending on the features, right? Uh, to figure out who this person is. So what you can do instead with machine learning is tell the computer, hey, these are the features of these people. So then figure out, learn that for these set of features, or for this particular picture, this is that particular person. So over the course of many repetitions of that and many different data points, or many different pictures, for example, it would learn that these particular pictures is this particular person. Right, so that's what machine learning is. So you don't exactly tell it how to do its job, but you tell it to do its job given some data. Right, so that's machine learning. So now, since our topic is about Azure machine learning, so we still have to talk about Azure. Azure is basically Microsoft's cloud platform. So if you're familiar with the cloud is basically somebody else's computer. No, and the cloud is basically mm, a fleet of like computers that you can provision, right? So you can request the platform to like give me this, or not just that, right? So your computing resources, instead of doing it on your local or on premise, like you have it physically there, you can rent somebody else's computer, like, so that's the cloud. So Azure is Microsoft's cloud platform, but the other major players in the field also have their own. Like for example, Google has GCP, the Google Cloud Platform. Amazon has AWS, and then IBM's IBM Cloud. So those are the major cloud platforms. Alibaba, right? And then next. So what is Azure ML? So since we can borrow a computer from the cloud, right? So we can just like use the computer to run machine learning, right? Yes and yes and no. Because there are, for most of these platforms, they have a recommended way of doing things. So for example, with machine learning in the Azure cloud, the recommended way of doing things is by using the Azure machine learning service. So yeah, well, before we have the DSVMs, data science, visual machines. So I'm not sure they still exist, but they're not the prime way of doing things, unless you're doing it on prem. So Azure Machine Learning Service is the recommended way of doing machine learning on Azure Cloud. So what basically Azure ML brings to the table is it allows you to create your models, manage your data, create pipelines, and generate. You can even like schedule your pipelines. If you want batch processing, you can create compute resources, and then you can deploy your models, and all that can be done like automatically. You just need to configure it, and then boom, you're done. So and oh, there are a bunch of stuff I did not include here, but we'll see that when we actually start with Azure ML. So with Azure ML, um, you have two basic modes of dealing with Azure ML. So you have the code way of doing things programmatically, and then you have another way wherein you can build models visually. And that visual way of doing things, there are two components there. We have AutoML, which is basically a ML for ML. So it basically makes a machine learning model for you. So instead of you programming the machine learning algorithm, you don't need to do that anymore. So that's AutoML. And then we have the Visual Designer, which is a drag and drop interface. So we'll try to explore these. So I'm not sure if we have time, but we'll first explore building models with the designer. So the designer in Azure ML is the visual drag and drop model builder. So you can drag your data, you can drag your pre-processing steps, and you can train your model and then publish your model. So that's basically what we can do with the designer. Right. So let's hop in. Let's see how we can actually start. So first is we need to actually create a machine learning uh, service, right? An instance of the machine learning service. So I have a machine learning uh, button in here that we can select. Alternatively, you can click create resource, and then you can just wait for it, and you can search machine learning, and then it's blocking the, but it's supposed to be the first result, right? Machine learning, it's the first result. Just, you know, believe me. There we go. That's it. So it's the first result. So and then you hit create. So then so you can select your subscription. I have my subscription in here. And then you can select resource group. In this case, I can create my own resource group. Um so for example, Azure ML to 2020 demo. It's RG. It's a bit long, but you know. And then workspace name would be this uh thing that we're making now is a machine learning workspace. Oops, sorry. Uh Missed it. Uh Azure ML to 2020 RG. Right. RG stands for research group. Our workspace name, because what we're creating is a workspace, right? So we'll say Azure ML because it doesn't matter too much because we're inside the resource group. A resource group is basically just a collection of free resources that are like, you know, logically grouped. In this case, for this particular demo, we have a resource group. Now, as a region, we can have whatever, but I'm going to pick Southeast Asia. There we go. So it's better to choose what's nearest to you. So, you know, review and create. Right. That's basically it. And then create, and then we'll start creating the. I forgot to connect my charger. So it's being created now. So we just have to wait for a bit. Shouldn't take that long. Oh boy. So alternatively, this process can be built programmatically instead of doing it visually. So if you download the um, Azure Machine Learning SDK for Python or R, for R, it's still in preview as far as I remember from their docs. They say it's still in preview, but if you want to build it programmatically, you can use Python, so you can create a workspace from code. Right, so it's almost done. It When it's done, we'll be able to see it in here. Right, so we can see here deployment is still in progress. So let's just wait. There we go. So it was created. So now we go to resource. So now we're here. But the actual fun stuff begins here when we click launch now. So when we open this in the Azure portal, we can see that we have this Azure Machine Learning Studio. This is the separate separate site that we can go to open machine learning, Azure Machine Learning. So we launch, and we'll be able to go to the Azure Machine Learning Studio. So before we had a free Azure Machine Learning Studio before, and that was the and now that is the Visual Designer. Okay, so and that the old Azure Machine Learning Studio has been deprecated. So now we're using the this Azure Machine Learning Studio we're using is now a combination of all the previous Azure Machine Learning services, and then the Visual Designer, right? So this is a combination of those. So now select a directory. This would be my, I think it's the default directory though. Let's see. I think I really think it's the default directory. Just nah, yeah, I guess it should be the default directory. Yeah, there we go. Oh no, not sure which one. Azure Workspace. So it doesn't have one. Just this one. Yep, here we go. Azure ML. So select the directory, subscription, and the workspace that we created. So this is the one we created, right? Yeah, there we go. So then we hit get started. Right. So now welcome to the studio. So here. So it says the steps here would be to register data, train models, evaluate models, and deploy models. Now, you can do this in a bunch of different ways in the studio. So let's will but here we'll be viewing the designer. So I'll just skip the tour. I'll tour you myself. Anyway, so in here you can create different things. Basically, the main ways that you can create models would be here in the on the left side. So we have notebooks, automated ML, and the designer. So previously, you needed to select, right. Previously, you need to select basic and enterprise, and with basic you only have notebooks, and with enterprise you have all of them, including the designer. But now we don't have that anymore, as far as I remember. So when I take a look at it, right, so I did not select basic or enterprise. I just created a workspace, and now I have all of them. Now, with notebooks, if you're familiar with Jupyter notebooks, basically just the same. It basically allows you to combine a documentation and code to. It's basically familiar. It's actually very familiar and popular with the data people. So those are the notebooks, and you can already access the um, Azure Machine Learning SDK from there. And then, but our focus today would be the designer. But if you have time, let's explore the other ones. So designer. So what are the other stuff apart from that? So in here we actually have the assets that we need. So first, data sets. So data sets would it would depend. We could have file data sets, and we have tabular data sets. So it depends on what you're importing, but we can manage our data sets in here. So you can version our data sets. For example, there we go. Yep. And then experiments would be for this usually a single experiment usually represents a particular script, and then for each experiment you can run that experiment multiple times. So you can run that script multiple times, and then you can see the metrics and stuff, right? And then pipelines. Pipelines allows you to uh, create modular steps for your machine learning pipeline to follow. So basically, like, for example, pre-processing steps. If you want to like reuse that step, the you can do that in the pipelines. You just have to specify that. But this is usually in the SDK. So the design is kind of like a pipeline, but it's not as robust as the code pipelines that you can create in here. And then we have the models that are actually created from these. You can actually like also version them in here, and you can view the metrics individually of the models that created. And then the endpoints would be how you can communicate with your model. So of course your model is just sitting there in a box. So how do you actually reach your model? That's what the endpoints are for. So these are basically like, well, it depends, right? Because you can have real time inferencing and batch inferencing. So this would be different kinds of endpoints. But usually you're concerned with real time. So we can send messages to our model and ask, like, for example, if for a picture example, like, I'll give you this picture, tell me who this person is. There we go. So at a particular URL, that's why it's an endpoint, right? Because it's a REST endpoint. Then we have the actual resources in here. So we can have our compute, our data stores, and data labeling. I haven't tried this before, data labeling this. But usually this is the data labeling that, like for example, if you see the um that's a bad example, captcha. So like you put squares in that, and you label it like this is that particular thing. Like this is a picture of a bus, or this is a picture of a traffic light, and you're not sure if the corner of the traffic light is still a part of the traffic light, but you click nevertheless in captchas. There we go. Anyway, so you can provision your own compute in here, and your data source is where your data sets are. So data stores and data sets are different. Your data sets are stored in your data stores. So you can like data stores store raw files, and then you can convert. You can extract data sets. You can build data sets out of the files in your data stores, right? But in here we're more interested in datasets. So what we're going to build would be a diabetes prediction model. So given particular information about a particular patient, is this patient diabetic or not? So we already have a file for that, a CSV file that we can import. So how do we actually create a dataset? So we just click create dataset. So from local files. So you have a bunch of different ways of doing things. I said earlier that you can create datasets from data stores, so you can get files from the data store, or you can also get from GitHub. You can copy a link from GitHub, a raw link to a CSV in GitHub, for example, and then paste it in web files. And from open datasets, you can just search Azure ML open datasets. They have a bunch of datasets there that you can use to actually practice training your models. Now, so for now, we're going to create a dataset. So I'll call this the diabetes. Diabetes. Oh, that's And then dataset version 1. Uh, there are two types. Again, I said, so we have tabular and file. And then this is basically we don't need to add a description for this. Just hide this, and then next. And there we go. So currently set date store. Okay, so workspace blob store is the default. So when you create a machine learning workspace, it comes with a default data store, but you can provision your own and then just attach it into your machine learning workspace. So you can have an existing data store somewhere from your storage account, for example, and then just pull it into your Azure ML workspace. That's fine. But in this case, I'm going to store it in my default blob storage. So and then I'll browse. That should be in downloads. Wait, where was that? Diabetes. CSV. There we go. Skip data. Yeah. Then I think we can validate that. To be fine. Should be fine. There we go. So we have this should be fine. So it's a delimited file because it's a CSV, comma separated values file, and then so the delimiter is a comma. So because it's a CSV, and then UTF-8. Yeah, should make sense. And no headers. Let's see if we have headers. Oops, sorry about that. Oh, there we go. Diabetes data set. We have headers, right? So we need to uh, specify that we have headers. Use headers from the first file. Yep, should be fine. Skip rows, we don't need to skip rows. And then we hit next. And then so oh, these are the columns. So we can specify uh well not right now. You can actually specify properties in here if it's available. So what we're interested in here is the outcome. Outcome is a numeric value. It's 1 or 0. It's 0 if you don't have diabetes. Of It's 1 if you have diabetes. And these are the information for that particular person. So how many pregnancies that this did this person have, glucose level, blood pressure, skin thickness. That's very serious. But then insulin levels, BMI. Not sure what this is, so we'll include it. And let's actually see if we remove it later on, if it actually like contributes anything. Okay, so next. So these are the basic details. Should be fine, and then we'll create. And well, oh, okay, so we have created already. So before we actually build the model visually, we need to create a compute first, right? So important thing here is the compute clusters. Okay, so the difference is you have compute instance, compute clusters, and then inference clusters. So compute instances is where your actual computing is happening. So for example, where we're running the experiment, but the actual clusters that are running the training of the model is in the compute clusters. Okay, so this will take more time. So we'll create this first. The ML compute got GPU dedicated. Just give it, you know, give it power. So much power. Let's open this for a bit. Uh, VM size. Oh, ouch. That hurts my feelings. Oh, because I already have. Yeah. So let's settle with the D12. Should be fine, I guess. D12, standard D12, V2. Number of nodes. Well, yeah, just keep it running. I'll just delete this after. So what happens is, if you're not running anything, if we select 0 in the minimum number of nodes, if you're not doing anything, it will scale down to 0, right? So you will see here idle seconds before scale down. So after 120 seconds, if you're not doing anything, it will scale down to 0. But we'll keep it to 1 for now. Why? Because I don't want to, because it's a pain to spin up a node once it's done. So it's easier to just keep one running at all times. And then the maximum would be 4. Event settings, anything? No, nope, 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 nope. We don't need that. You would need this if you were going to SSH to your machine, but we don't need that. It's great. Great, 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 great. So creating, this usually takes a while. So then we'll head on over to the designer. So that will take a while. So hopefully it gets complete soon. So now we'll go on over to designer on the left, and then we'll hit the plus button in here, plus, and then it's waiting. My internet's really bad. So okay, draft settings. Okay, so compute target with I okay. So we already have that. So that's our compute target. Again, that's where we're going to run the the training, actual training. So now, first thing, we'll call this the diabetes pipeline. This is a visual pipeline, different from the usual code pipelines that we have. These are honestly better, I think. But there we go. So we have diabetes pipeline. So first thing that we do for machine learning would be to bring in your data. So bring in our data there. Just it's that easy. So if you've registered, all your registered data would be data sets would be in the data sets in here. So we can just drag that in. We also have sample data sets in here, right? So if you don't, alternatively, if you don't want to use this data, right? Time check. Okay. So If you don't want to use this data, you can input data by yourself. You can say enter. I think it's enter manual data manually. There we go. So you can bring this in and you can just plug your data in yourself. But this is more helpful because this is versioned and it's already been treated like CSV. It's already been created into that. Because under the hood, it becomes sort of no, not sort of. It becomes a data frame, right? So it becomes sort of a table. So that's what happens in the back. So if you just plug in manual data, it's just text, and then you have to deal with it by yourself. But it depends on the data, right? Because enter data manually still has pretty good uh, processing of your data. So like it will determine if it's tabular or whatnot. But this is still way better because it's already been being managed, and you can update this with better data. For example, if you have updated data, because you can version it. Now, too much thinking. What's next? So we have our data. Do we need to process this? What kind of processing should we do? Do something like normalization. Oh well, let's look at our data. Yeah, yeah. But so you can actually like hit visualize. So okay, sorry. What I did was, so now I've dragged this, right. You can click this button in here, and then right click it, and then visualize. So you can actually see the features of the data. So if you look at this, it's all over the place. Yep. So pregnancies range from 0 to there's 13 pregnancies. That's wow. So we have 0 to 13 pregnancies, and then glucose level. So the data is all over the place. So you can see the distribution of the data in here, right? Yeah, skewed. Uh, yeah. And then when you click a particular one, you can see even more details. So like you can see what it is. So it could be numeric, it could be categorical, depends. And then we have the other details here. Measure standard tendency, skew, etc. And you can see it here. You go. So important stuff, unique values, and then missing values. So in here, no age was repeated. They're all unique. In here, pregnancies also don't have that's I don't believe that because we have duplicated. Yeah, yeah. Sorry, I missed that. So unique values, all have been repeated. Same with here, all have been repeated. So we have zero unique values, and we don't have missing values. We don't have blanks or nulls, right? Perfect. But this is all over the place, right? So we have to deal with that. So you can either standardize it, normalize it, but I don't think standardization makes sense in this case because there should be no negative there. But okay, so I think normalize works. So just drag it in there. So it's going to be oh yeah, it depends, right? So oh yeah, yeah, it, yeah, it's just another. Yeah, so if we use z-score, it's already standardization. So let's just pick min max. Should be fine. Zero for constant columns and check. Okay. Columns to transform. What columns are we going to transform? Well, basically everything except for the outcome because it's already normalized. How normalized can you get? You already have 0 and 1. There's nothing else. Here we go. Save. So let's take a look at this. Right now we have so we've dragged this from the left side. We searched normalized data. We dragged this in here. Then we connected them. So the data here will flow here. So what we're building here is a pipeline. The flow of the data, you will see it, right? So you can visually see how the data is trickling down, what these steps are, what steps are happening, and what step you are in when you're training. You can actually see it in here, right? So I don't think this matters too much because the important stuff in here, right? So and then we hit submit. diabetes pipeline. So create an experiment. Yeah, create a new experiment. This would be um, diabetes, visual diabetes. So it should be fine. And then we'll create uh, visual diabetes pipeline. Submit. This will start again. I told you earlier that experiments have multiple runs, so like we can run this over and over again in the same experiment. Yep. And then we can actually, like, see the metrics in the experiments, but in this case we don't have a model and any metrics, so it doesn't make sense for us to, like, check the metrics. But yeah, let's see. So this will start running, and then we can take a look at uh, the details. So far, nothing happening yet. Nothing exciting yet. So there we go. So we already had processed this, right? So it's just working on this one. Still good. So this is the part that takes a while, especially if uh, in the designer, right? So running this on, and it depends on your computer. If your compute is not that uh, good, so this will take a while. Alternatively, if you're not using the designer, actually, you can use your local as the compute. So you can, in your experiment, right, if you're not using designer and you're just coding, you can specify that your target is your compute instead of creating a compute. So it won't run on the cloud, it will run on your local. So what it just does is it downloads a Docker image with all the packages needed in there, and that's what it uses to run in your local. Well, it assumes that you have Docker installed. Okay, so it's running. So when it's done, we'll be able to see that our data has been normalized. So yeah, it's taking a while. Uh yeah, for well, that's running. Are there any questions? Oh, that's Inception. Yeah, it's still running.
Hello.
Hello.
While we're waiting, there aren't any questions on YouTube or Facebook yet, but maybe I have one question. So you were picking these different compute instances
Mm-hmm.
before, and I guess, of course, we don't want to talk about pricing so much, right? But what is a good instance to start with? And then you also mentioned running this locally. How does that really work?
Okay. So the local run is only. So I'll answer that question first. The local run is only available if you use the code the code based way of doing things. So that would be like if you're using notebooks, if you're using the Azure ML SDK for Python or R. So that's how you can use your local machine for using um, Azure ML. And then for the compute instances, I think it's better to, at the very least, you start with something at which has 4 GB RAM, right? At the very least, and then for CPUs, for CPUs. Good enough would be for CPUs, and then 8 GB. For what we have here, I selected, I think, 28 GB, and then for CPUs, if I recall correctly. So, but I will delete it anyway, so it doesn't cost that much. And then the minimum of nodes would be good enough would be three nodes. But if you're doing it in production, you need to increase that, because even if you're just testing it, um especially with many people working on it, if you only have 3 nodes, that's going to be difficult. Anyway, so um I think we can entertain other questions later. But for now, we have finished the normalization, so we can actually right click this again and then visualize like we did earlier. So after the processing, we can see what the data looks like now. So now we've restricted the data from 0 to 1 because we selected min max. If we selected a z-score, that would be -1 to 1. Sorry about that. So there we go. So we actually like shrunk the values. So why are we actually doing using this? Because it works well with machine learning algorithms if we reduce it to the scale, because of just how the math works in the algorithms, right? So there we go. So this looks good. And now what we need to do is uh actually need to split the data. Split the data. Okay. So why do we need to split the data? So we need to split the data because um we don't want our machine learning algorithm or machine learning model to actually just memorize the data. So if you give it 100% of the data, then we give it the same data and then tell them to determine what these are, then obviously it's going to be really, really good at doing that because it will just basically memorize it, right? So it doesn't make sense. So what we do here instead is to split the data into different sets. So a training set and the test set in this case. So and then what happens is we'll train it on, in this case, so we will say it's zero point 0.7. So we'll train it on 70% of the data, and then we'll test how good it is on 30% of the data. Okay. So that's why we use split data. So we don't overfit our data, right? So it doesn't memorize our data instead of learning, because like people, learning is different from just memorizing. So you want it to actually learn to some extent. Yeah. So that's why we're splitting the data. So split here, then this is new. Haven't seen this. But this is what you usually do. We split it into 0.7, 70% to the left. That would be our train set. So this would be 70% of the data. And this dot right here on the right side would be 30% of the data. I don't know what this is. Indicate where the rows it splits will be grouped using as. Oh, okay. So grouping would depend on a particular column, but no, we won't do that. Right, so split the data. Once we have our data, now it's time to actually train our data. We can actually still like do a bunch of steps in here. Like, for example, we have clean data, clean missing data. So you're able to, like, for example, drag this in and then specify how you deal with the values in the data set, because you have a bunch of ways to deal with the data that you're. If there's missing data, like you can impute, meaning you can interpolate and get what data should be there, or maybe you can use the mean to place it in there, or you can just drop the whole row if a column has a missing value. So that's an option. So enough with the pre-processing. So we have split our data now, so we have to train our model. So just search train. It should be in here. There we go. We have train model. So we drag it in here. So this problem is what we call a classification problem, because we're trying to classify. Wait, what's happening? Oh, sorry. This actually fits in here. There we go. So this is a classification problem because we're trying to classify if a particular person, which is signified by the row in our data, is diabetic or not. So you're classifying them into diabetic or not diabetic. Uh, and then specifically this problem is a binary classification problem, because binary, we have two classes, so it's a binary classification problem, also known as a classification problem, but it depends on who you talk to. So there we go. So train model, and then we search for an algorithm that you want. So in here we have a bunch of drop downs, right? So we have data input, accordions, whatever we want to think, data transformation, and then whoa, feature selection, statistical functions, and then this is the important part, machine learning algorithms. There we go. So you can pick an algorithm here. So we have regression algorithms, we have clustering algorithms, classification, and oh yeah. So they have their own algorithm for recommendation, which is, for example, in here. So right. So alternatively, so if you don't want to pick from one of these, you can actually say execute. I think that is that in execute. Yeah, Python script. Execute Python script or execute R script or create Python model. Yeah, you can create Python model. So that's for models, and so you can actually just place your code in here, like actual custom Python scripts. So you'll be accepting a data frame, which looks like a table. If you're not familiar with data frames, they're basically just tables. So there you go, create Python models, and then if you want to code in SQL to pre-process your data, you can use SQL transformation. Apply SQL transformation. Can never memorize this. Just keep forgetting. There we go. So train model. So we can plug in our algorithm. In this case, we'll have to search for classification. Classification. There we go. So pick one. Huh. Let's see. Okay. So multi-class. There should be a two class. There we go. Two class. So we can pick one of these. So let's start with the simplest one. Let's pick logistic regression first. As a friend says, start with the simplest one first. There we go. So we have you're in the way. I don't know how to. And just actually drag this to the right side, and then we can plug this in here. Now that we have, so we can actually like train this. Okay. So yeah, but before that, uh, then this will actually like put the data into our training, and then plug in the algorithm that we're going to use, and then it's going to start training. And then again, so we have options in here. I think this should be fine. Auto regularization should be fine. Yeah, that's fine. It's fine. Uh, right. So, before we start, we need to specify the label column. The label column is what we're trying to predict, which is the outcome, or whether you're diabetic or not. So we can specify in here. The label column would be the outcome. It's autocomplete, so we're good. So that's what we're trying to predict. There we go. So now that we have a train model, we can then give it the remainder of our data, which is the 30% of our data, and plug it in, and then let's see what the results are, if they're actually like if it's actually performing well. So that's score model. So we drag it in here. We drag this in here. So that's our model. So you can actually like hover and see what needs here, what is needed here. So we have in here trained model. That's what we need. And this dot, in this other dot, we need the data set, which is coming from here, because this is the 30 split, this is the 70 split. So we drag this in here. Probably being cursed by the mathematicians watching this already. Blasphemy. But anyway. So we have split data, train model, and score model. So when we run this will, we stopped at normalized data, right? And then it will continue flowing in here up to here. Then we'll be able to see the results of our model when it is all done. We can again visualize. So we'll submit. This is the second run, same experiment. Then we hit submit. takes a while. So, what should we talk about? Are there any questions from the audience?
Hello, yes. Should we take one? Someone from
Yeah.
Facebook has asked, let me just post that. This is from, I think it's from, let me just check. We can't see the name here because it's not allowed. Jojo Badong. Can you see the question?
Uh,
So is there a package in here that helps clean up the data, such as detecting and removing null or zero values?
oh yeah. There we go. I saw the yeah. Yes. Yes. Uh, I talked about that earlier, right? So that's the clean missing data. It's I can show it later. So you can use the clean missing data package, sorry, module. You can use that module, or you can create. You can use the execute Python script module. So it will take a data frame. It will take a data frame or two, and then you can start processing the data frame. The incoming data frame is a pandas data frame, not a PySpark, not a Spark data frame. So you can just work directly immediately with it. So if you're familiar with pandas already, that should be fine. I'm not sure though if yeah, no. So in here we don't in the designer we don't support Databricks. So Databricks would be the platform for Spark and big data for in Azure. So that's Azure Databricks. Well, Databricks is a different thing, but we also have Azure Databricks if you want to integrate it with Azure. So basically, can have your big data, uh, your Hadoop ecosystem, and then use Spark to just read off from it. And in our programmatic way of doing machine learning, which is the Azure Machine Learning Python SDK or RSDK, we can actually deal with Databricks. So like the DBFS files from Databricks, we can actually deal with them. So your data frames are not, as clean cut as you want. So it could either be it could be pandas data frames, or it could be a Spark data frame. But if it's a higher version of Spark, you could convert it using df.to pandas data frame. So it becomes a Spark data frame that has the same interface as pandas. So anyway, I digress. But yes, we do have that module. We have a clean missing data module, and alternatively, you can use the execute Python script module for your custom clean up tasks.
Thank you. I hope that answered your question, Jojo. Otherwise, you can still post your comments on Facebook. Do we have time for one more? Or do you want to continue?
Yeah, I think we have time for one more. It's still running.
Cool. Then I'll take one more, also from Jojo. Jojo. Do you know Jojo? Jojo.
No, no, no. It's what the anime?
All right. So the question is, how about detect anomalies such as high maximum and minimum values that may make the training results inconsistent?
There is a module for that, but I have not tried that before. Uh, no, it's lagging. There we go. So we have a PCA based anomaly detection. I have not tried this before. So principal component analysis. So it basically uses the functions that you have. So and then determines if you have an outlier based on the previous ones. So I've not tried this before. Although PCA, if I recall PCA, I'm super like out of it already. I haven't done this in a while because I'm more into data engineering now. So if I recall, PCA like removes features that are not really helpful for your model. So I think to some extent you can use that for anomaly detection. But yes, we do have a module for that, but I have not tried this before. So what alternatively you can have yeah, but you can yeah, you can do it here. You can use the execute Python script to use scikit-learn also, but that's easier if you do it in the Azure Machine Learning SDK. It's way easier there because you can import all the packages in your script and then plug it into experiment. Uh yeah. You can actually take you can actually like, take a look at these. So if you apparently if you're using the anomaly detection, you won't use train model. You will use this train anomaly detection model, which is a special kind of model. This is also the same case with recommendation uh, and clustering. You don't use train model. You use a different module for just specifically for clustering, and you also use a different uh, module for scoring it because there's technically no score. You're 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 doing the model for you're using the model to break the data up into clusters, so it's a different module as well. But yeah, so we do have modules in here for those if a value is going too high or too low depending on your previous data. But I have not used it before, so you can actually just try it. So one good thing about Microsoft is it has the doc in the modules, has documentation in there, so you can go pretty deep with these. So these are pretty detailed, these modules, uh, those docs for those modules. Okay, so I guess that I hope that answers the question. But so basically, we do have that function, but I have not used it, so I can't tell you how to use it. But there is. Now, um, so we've completed training, right? This is actually pretty quick than what I expected. Because previously, before when I do this, I just use a single VM with 4 GB RAM. It's horrible. Now we used 4 and then 28 GB. It's really good, right? So we have scored it, and then actually, what makes us a bit slow to some extent when compared to just running it directly is because we're collecting logs and details. So it actually makes that a bit slower. So if you actually like run this, if you run it pure code, it's actually faster, but you don't have the extensive details of the runs that you can see on the UI. But also because if you even if you run it in Azure ML SDK, right? You can still see it, the details of it in this site, ml.azure.com. You can see it here. Even if you ran it locally, it will upload the details of the run in here. So you can see it in your beautiful. You can see it later in the experiments. Anyway, pregnancies, glucose. So we have, if you take a look at the outcome and the score probabilities, this is the outcome is the actual in the data if this person's diabetes or not, and the score probabilities is our guess how close, zero, how close is it to one, and then how close it is to zero. The closer it is to one, the more leaning it is that the more probable it is that the person has diabetes. And if it's closer to zero, then the lesser the higher probability that the person doesn't have diabetes. Now, so outcome is one in here. Then our score probability is 7.0.7, so it's closer to one. So the guess is probably right. And then here's the actual score tables, right? So we cut it into, if it's above zero point 0.5, then it's 1, it's below zero point 0.5, it's 0. So if you can see here, it almost matches everything. 1 1 1 0 0 0 0 0 0, and then we have 0 1. This doesn't match. So, and then we have 0 0 0 0, and then 1 0. So this doesn't match. 0 1 1 0, this doesn't match, doesn't match, doesn't match. So a bunch of stuff that doesn't match. Okay. So how do we actually, so we know that it matches and it sometimes doesn't match. So how do we actually know the performance of this model? So we can actually pull out evaluate model. So this will use various metrics to actually see how good our model is performing. So plug it in. There we go. We don't need anything in here if I recall correctly. Yep. So then alternatively, uh, ayun, we can take a look at clean missing data. So so the question earlier. So you can select cleaning mode. So what's you can select, replace mean, like I said earlier, or you can like just delete the whole row. They don't have, actually you don't have, yeah, you have custom substitution value in here, or you can, so the thing is they don't have the impute the calculation, so that's the sad part. So if you want to impute your out of luck, you have to use the Python SDK. But if you just want to replace it with mean, or you want to remove the entire row, you can do it in here, right? So you can just select the columns to be cleaned in here. So that's clean missing data. Now, so this is the last step, evaluate model. We'll see how, I don't know, this is the second to the last step, because finally at the very last step, we'll deploy our model. So we'll submit again. So this won't run the previous steps anymore. It will just run the evaluate model because that's the last step. So hopefully this will be quicker and then we can deploy this. Yep. So last step. It's queued. Let's take a look at our other stuff in here, especially for data transformation. What do we have in here? Apply math operation, clean missing data, clip values. Interesting. But you're losing information. So convert the data set, join data, normalize data, partition and sample, smooth. I read about this. I didn't understand what it was about. Split data. Oh, that's basically it. So now our evaluate model is running. So it should finish soon enough.
Hi again. I'm just going to join you so that we can maybe talk a little bit while this is running. I'm just going to
Right.
pretend that I'm now a machine learning expert, that I understood everything that just happened. But one thing I can tell for a newbie like me in this space is that seeing this visualization kind of make me appreciate what I can do and understand the process of training your data and cleaning your data and doing your computations and evaluation. But my question is, I'm a developer. Do
Mm-hmm.
I need to have a machine or a data science degree or something before I can develop a solution that uses Azure machine learning? Or is there like a quick path for me to just build something maybe simple if my boss one day would come to me and tell me, hey, I need this solution that can detect all this um, probability of being a diabetic. What is your advice? Can a developer just be able to work with this, or it's best to really go deep into data science?
I think for a quick one, right? If you want to like create a prototype, like for example, this you can just jump right in and just plug stuff in, and then if you need to refine it, like for example, if you want to pick a better machine learning algorithm or pick the hyperparameters or the settings for the machine learning algorithm, then you'll definitely have to bring in your data scientist. But if you want to get started with it, like if you can just drag your data in and then process it and then train it, and then afterwards you can publish it and then build your app around it. So just you can just have a demo of sorts to your for your clients, for example. So this is a quick and easy, quick and dirty way of doing things. But
All right.
if you really want to like, you can really tweak this if you want, because you can specify we can see it right now. You can specify the settings, really, like the regularization. You can specify it in here. Like it also depends on your algorithms. And if you want really if your data scientist wants a customized solution, they can use the create Python model or execute Python script modules. They can pick one of those and use that to create the model, a custom model for your pipeline. But they'll only change one part, right? They'll only change this part and plug it into here,
Mm,
and the rest would be the same,
all right. Thank you.
right? So now we have. Thank you for the question. We have completed the all the steps. The next part is we need to create an inference pipeline. So when we say inference pipeline, the data will flow through the data coming from the users will flow through that pipeline and then return to the user. Okay, so we'll hit, in this case it's a real time inference pipeline. So this will create a new pipeline from our existing pipeline. So it will reduce the number of steps because we don't need to train the model anymore because we already have a model, and we don't need to evaluate it anymore because we're not in the training phase. The evaluate model would only be read by uh, you only be reading it, but it will not be used by the user. So what the user is concerned with is the web service output. So in here we have the web service input. Yep. So it's coming all into apply transformation. Apply transformation is actually what the steps that we did before our model. So this is our model. So it will plug all the data in here, process it, and then put it in the score model along with the model, and then we'll wait, select this thing. Oh, one thing I forgot. So we created earlier the compute targets, right? But it's a different story for the deployment. So deployment, you have, I think, two options. So the inference clusters is what you need to look for. So inference clusters, you need to create either. Wait, do I even have a choice? Oh no, I don't have a choice. Huh, that's weird. I seem to recall. I think so. Maybe in this mode you can only choose Kubernetes, but as far as I recall, you can choose an ACI, an Azure container instance. So just a Docker instance container, not a whole Kubernetes cluster. But in this case, there uh, deploy. So let's just call it AML deploy. In this case, we only have Kubernetes as the service choice. Then Southeast Asia. The machine size, it could be smaller now. We'll just pick dev test. Yeah, I think a D3 would be fine. So for production, again, the minimum is 3 nodes, and for dev testing, you can have a minimum of 1 node. Then this should be fine. We won't be SSHing inside. So then create. So this is where we will be deploying our service. Okay, so it's creating now. So this is a Kubernetes cluster, right? So even if you have 1 node, you can have multiple pods in there. So it depends on the it will scale depending on the amount of, actually I'm not sure what the, because in Kubernetes, right, you have different uh ways of doing HPAs, the horizontal pod scalers. It depends. It could be memory, CPU, could be traffic. It depends. I'm not sure what they're using here, but it will auto scale. Uh, so it sets designer. So let's take a look at our real time inference. So it's still running. So we don't need these, but we're just using it for reference in our evaluate model. But if we remove these two, we don't need this anymore. We just can remove it. But for now it's fine. The users won't see this anyway. So again, so like even if you have a lot of transformation steps, like if you have normalization, and then you have transformation, and then you have cleaning steps, it will all be reduced into this one step apply transformation before you train the data. So uh, that's what apply transformation is. So we could be done already if you don't have this. Uh, this should be finished in a bit, and then after that we'll hit deploy, and it will deploy to our inference uh our inference cluster, our inference Kubernetes cluster. So high availability. There. No questions from my post. uh right, running the model. What
Hello again.
else?
every
Hello.
time you uh, every time you say questions from the post, I just pop in. Well, we don't have a question, but we have again a very very nice comment from our friend Jojo here, saying that compared to building models in our studio, this is heaps easier. Plus, I love the integration with different packages, which you can just drag and drop. Do you feel the same? Do you have also experience with other tooling for machine learning? And how does Azure ML tooling compare?
So hmm yeah, no, I can't really.
I guess there's always pros and cons with different tooling.
I mean, like, this puts me in a bad spot.
Yeah, no, we don't. Just a question I invented. Don't worry. He was just saying a very nice comment here.
I
So,
have but I have tried a bunch of stuff, but I won't say bad things about them.
no, 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 no. Of course not.
But I can compare this with its previous version, because again, as I said earlier, this is this is the spiritual successor to the previous Azure Machine Learning Studio, because the previous Azure Machine Learning Studio is just the visual designer, and then we don't have the notebooks. The notebooks were a different thing. We have notebooks at Azure.com, but that is being deprecated soon. So this is now the unified uh, everything for machine learning in Azure. So like if you do if you want to do auto ML, if you want to build designers, note and the notebooks. Uh, yeah, something I forgot, right? So Miss Marilag, you asked me earlier about if a developer will be able to, like, do this without any fuss or whatever. So they can with automated ML, because with automated ML, you don't need to add the cleaning part. You need to add the pre-processing part. You don't even have to specify what kind of what algorithm to use. You just have to specify what task it is. If is it a regression, is it a classification, or a time series? Uh, we don't have recommendation yet, sadly, but those are the three we support. So basically in AutoML, you just plug your data in, and then off goes your model. That's it. And then once you have your model, you can just deploy it into your cluster, right? So that's how easy it is. So in the designer, what we did is plug in a bunch of stuff. Like we added the splitting of the data, we added normalization in and we specify the algorithm in AutoML. You don't need to do that in AutoML anymore. So if you're a developer, that's really really easy to use. So that's in Azure ML. So if you want to utilize very powerful compute on and off by at will, you can use automated ML. And then they have a bunch of features, like if you don't want to specify, or if you want to specify what pre-processing steps you want to take, or if you want to specify which algorithms would be selected by the AutoML, in because it will try to select different algorithms, right? Because it will try different algorithms to see which one is the best. Uh, so in AutoML, you can specify that. We also have a version of that if you're a .NET developer, if you're a C Sharp or a VB.NET developer, or an F Sharp developer. You can use the ML.NET library. So they have the ML.NET CLI has the auto ML feature. It's actually the only feature it has right now. So MLNet auto train. So what you can do is also the same, plug your data in, it will generate a model for you in like minutes or less than a minute. Depends on how long you want to train. And then the results are pretty great. But the difference from there and here is that we have more options in automated ML. Like you can specify which pre-processing steps you want. So those kinds of things. Uh, Again, so if you're a developer, it just a pure developer, you don't know anything about machine learning, automated ML is your thing. And then um, with automated ML, you can just deploy it automatically to a cluster that you have provisioned. So that's the easy part, because that's really easy in here, because in my experience for building uh, because it's easy to create ML at auto train model, right? But the thing is, you need to build the API around it with the security and stuff, and like how you
Mhm.
accept the data, how you return it. So that's the hard part. When I actually do demos on ML.NET for auto ML, that's the part that takes a while, because the building the model part, it's really easy.
Mhm.
And in AutoML, that's not the case anymore, because you generate the model really quick and then you deploy it really quick. And we'll explore later if we have time. But we also have the feature of model explainability, interpretability, so we can see why the model did that particular decision. But let's see this first.
All
uh
right.
Deploy. So we deploy a new real-time endpoint in our AML deploy Kubernetes cluster that we provisioned, and then we hit deploy. So while that's deploying, I'm assuming if we go over to models, we can see the nope, we can't. Why not? I think this is the models on if we register the models, but we did not. to register the model in here. Ta-da. Images. So in wait. So in here it doesn't really have a lot of logs, but if you're doing it uh programmatically, you can specify the logs that you want, so you can make them appear in here. But we can actually, like, still do it in there, but we didn't really open all the options when we ran. So we have the explanations in here, um, but we don't have the model, weirdly enough. It should be appearing in here. Oh, there we go. It just didn't refresh. So we can hit explanations, and still we need to deploy. It's still being deployed, so we can't see it yet. So after it's deployed, we'll be able to see the explanation. So what the explanation does is, it shows you how much a particular feature affected the decision of the model. So that's what the explanation is. So for example, if the highest contributor is the insulin level or the glucose level, you will be able to see it there. They have a graph for that, so you can see which are the most important features for that model. Because a model is just a black box you can't see inside. So what they do is they have specific algorithms to they they have a lot of algorithms to actually figure out uh, what what features are actually contributing the most. So they have black box models, for example, to like they're duplicating the model, and they're trying to figure out what features actually like contributed the most when they duplicated the model. So, right. So now we have deployed our model. So how do you actually use this? It should have. Oh, we have app insights. Ah, it's enabled by default. Um, no, not yet, not yet. I'm pretty sure authorized. It should have. I'm missing something. It's still deploying, because what's good about this is that once it's deployed, you'll be able to see sample code that you can run to actually make the request. Because now we have our endpoint. So this is our endpoint. So we can send a get request in here, or was it a post? I think it was a post request, and then we just have to specify the headers, the proper headers, right? So we just specify the tokens and the headers that we need, and then the actual request body. There, I was lost. So it's still transitioning. Oh, okay, so this is the part where I'm not sure how long this will take, because we only have created one. Uh, but I guess we don't have time anymore. But yeah, so once this is complete, you'll be able to see a sample, or at the very least a link on how to actually use it. Like, you can it has a uh, how you can use it with curl, and then Python and R. I not sure if there's R, but I'm pretty sure there's C sharp, Python, and JavaScript. How to communicate this particular endpoint using those programming languages. And then, the curl commands, you can just test it out with curl, to see the results. And you also have the sample structure of the data you will need. So you actually, after deployment, you have all you need for actual uh for the actual deployment. for the actual consumption of the endpoint. So, are there any questions?
Well, now we're nearing the end of the session. So if you still have more questions, just feel free to post it on YouTube or Facebook, wherever you are. Otherwise, I think we have a winner already. Well, this this is super interesting also for me and ultimately helpful, JP. So one thing is maybe not a very technical question is you mentioned that, for example, in your company, you're not using cloud yet that much. And I'm sure there are many companies also locally that are very interested in investing into machine learning. But what would be your advice to them? It's like when to do this and how to get started. What kind of team do you need to build and what do you need to look for?
Hmm.
Mostly for the companies in the Philippines, right?
For on per. All right. Hmm. The good thing with this is you can actually like run it here, and then you can actually run it in your workspace, and then download the model, and then um, just create an API over it, because that's still possible if you're using .NET uh,
Mm-hmm.
or ML.NET. You can do that. So the model in here, you can download that. So if you look at it here again, you can download this model, and then you can use it with ML.NET. So you can use C sharp or F sharp, and then wrap an API around it. So, and then you can use that if you really don't want to use cloud. And also alternatively, if you don't want to use cloud, uh, you can have cloud, but then you can do the training locally. So you just have to specify that the training is local, but then you're missing out on the flexibility of the compute. So you can create spin up very powerful compute for just a fraction of the time that you need, and then just spin them down when you're done. Because for example, if you're doing this on uh, locally, and if you want to use really powerful computers, then you have to buy powerful computers, and then if you're not using them, they're still there. So you just made a huge investment that maybe is wasn't it wasn't worth it. So I think this the cloud is more flexible. So but it depends, right? Because sometimes you have restrictions. So if you don't really want to use cloud, there are still other ways to do it. So one way is to use ML.NET if you're a .NET developer. And also I forgot to mention that the Azure machine learning is library slash framework agnostic. So it doesn't care if you use TensorFlow or PyTorch or scikit-learn or whatever you want. So it doesn't care, as long as you are able to build your models in a particular format, right? So there you go. Um, so if you really want to build locally, you can use ML.NET or whatever framework that you want. And then if you want to do AutoML locally, again, you can use the .NET ML.NET library for machine learning. And we also have um, so that's one option. And we also have Microsoft NNI. Microsoft NNI. So Microsoft Neural Network Intelligence. This is another tool that you can use locally for AutoML, if you don't want to use the AutoML ML.NET for ML.NET. So this is more flexible. This is more powerful. This is more flexible than ML.NET, because it handles basically any machine learning task. Doesn't have to be
Mm.
just limited to just classification, regression, or time series. And it also handles neural networks. but it depends. So you have NAS, you have neural architecture search. So it builds the architecture for you, which is something that is difficult, which is the main thing that data scientists do apart from dealing with the data. If you're building the model, you build the architecture, but uh NNI has the ability to build the architecture for you. But last time I checked, this is only applicable for PyTorch. Not sure which other, if it's added support for other frameworks as well for neural architecture search. But for the other ones, it supports basically any framework. So that's Microsoft NNI Neural Network Intelligence. It's open source. You can use it locally.
All right, thank you for that. But it's also, I mean, to encourage more companies to start looking into using ML in the cloud or Azure ML. But I can understand, and of course, some companies would like to transition and maybe try it out first on their own environment, and then move into hybrid, and then move into full cloud later on when they are ready. So but it's really nice to know all these different alternatives and different options that we can use to get started. Yes, I don't think we have any more questions. So any last words from you, JP, before we end this session? Or is it done yet? I'm sorry, is it something
No, 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 no,
still
I'm
running?
good. I was just
Okay.
any last words like I'm gonna die or something.
Just for this session. Sorry about that.
uh,
Final
it's fine.
advice.
Right. So if you want to start with machine learning, the easiest. So there are other ways of the doing it. If you really want to use the cloud, you can use. If you're starting out, you can use automated ML, or alternatively, you can use the cognitive services of Azure. So you have the Vision API, Speech API, those kinds of stuff. So they're already there. You just need to use them for those tasks. But if you have tasks that do not fit those criteria, you can create your Azure Machine Learning workspace and work with either the notebooks, automated ML, or designer. But if you're starting out, I recommend using automated ML, especially if you're building prototypes or you don't really understand still a lot, but your boss wants you to build something quick and working. So that's what you can use. And then if you're comfortable with it already, you can start building in the designer, and then deploying it. And then if you really want to, like, get into the nitty gritty of it, you can start building notebooks and deploying the models there, so that you will use the Azure Machine Learning SDK. So that would be a programmatic model building and deployment. So the good thing about this platform is it handles a lot of things already for you: data management, experiments with logs and metrics, and explainability, and then the deployment itself on a very high available on a cluster with high availability, the Azure Kubernetes service. And then you can provision your own very powerful compute just for training, and then when you're done, it will just scale down to zero. So that makes your life with machine learning really easy. So if you want to deal, especially this is very production ready, so you can just build your if you're using the cloud, you can definitely use this, less hassle when dealing with machine learning. You don't have to worry about the deployment yourself, about the training compute, how you actually run it onto different machines. You don't have to worry about that anymore. And then, so that's it for Azure Machine Learning. Um, it's hard to think of things to say at the very end of the talk.
Well,
Uh,
how can they reach you if they have some questions or if
um,
they need help?
right. I think you can reach me on Facebook, or just, yeah, Facebook. Because in my email it might go to spam. I don't know. So you can search me on Facebook at Paul Nugget Ada. I just tell me that you watched my talk on
Asig
uh
Manila.
yeah. And then because I'm not sure if, because my notifications are really bad, so sometimes I won't be able to see the messages. So but anyway, if I have time, just tell me, if you just tell me, hi, I watched your talk on the virtual event of Azure Manila, and then of Azure User Group Manila, and then tell me what your question is, if you want advice or what. So I guess that's it for me, unless there are any other questions.
Well, first of all, I just really want to thank you for using your time on this. I appreciate it a lot. And I hope you can continue supporting Azure User Group Manila and all the other communities in the Philippines that promotes software development, also cloud development specifically, and also artificial intelligence. So this is super helpful. And I just want to thank our audience for today. And Jojo, I owe you a goodies. So we're a little bit of a stalker here. So we're just going to try to find where you are in the world. Now, please write me on Twitter or on Facebook. Do you have a comment so how we can reach you? Or I'll message you on Facebook or something, and then we can send the goodies to you. So thank you very much for attending, for using your time on this. And if you know someone else who would like to share their knowledge on Azure, please get in touch so we can have you on stage, because we're always looking for supporters and volunteers and for members so that we can grow our community and so we can learn together. And thank you very much, JP, and I hope everyone stay healthy, take care, happy building. Thank you very
Right.
much.
Thank you very
Bye.
much. Bye.